All right, so let's take a look at knowledge check 5.4.4. So this is going back to our predictor variable being year built, and then we want to look at the relationship between that predictor variable and the sale price. So we saw in the previous knowledge check, we wanted to visualize the relationship between year built and sale price, and we did that with this code. And we can see that we do have some relationship here. Whether or not it's linear, that's a whole nother question, but we do see that it is increasing, and it seems to be increasing more so in the latter years here. And then we followed that by computing the correlation. And so when we looked at the correlation, we saw that the actual correlation was just a little bit over 0.5. So we kind of have a moderate positive correlation between those two variables. So now let's kind of build on that knowledge, and let's create a simple linear regression model where sale price is a function of year built. And so we can do this, and here I'm just gonna call this a linear model. In this case, model 1, and so I need to use linear regression, right? Creating our model object, and then I want to go ahead and fit the model, which is going to be sale price is a function of year built. Then we need to supply it our data, which is Ames train. All right, and once I create that model, I can just use this tidy function on top of it, and that will produce our model output. So let's go ahead and run this. And we now see that we have our intercept coefficient here, but more importantly, we have our year built intercept. So in this case, our intercept, or excuse me, our coefficient for our predictor variable is 1,489.86. Right? So we can pretty much say it's about 1,490. And what that means is for every 1 year newer that a home is, that our linear regression model is estimating that we see an increase in the sale price of about $1,490. Okay. Now, is this coefficient statistically significant? Well, we can see our p-value is extremely small, pretty much equal to 0, which we can also see that with our t-statistic here being over 30 standard deviations away from 0. So we can have pretty strong confidence that our coefficient is statistically different than 0. So one thing we can do is we can go ahead and look at the confidence interval. And the default confidence interval, we can see that here is level equals 0.95. So we're going to go ahead and already compute that 95% confidence interval. And so we're going to use LM-N1, and I need to pull the fit out of our object here. And now when I run that, I get year built. Our 95% confidence interval is ranging from 1,394 up to 1,585. Right. So basically what we're saying is we have a 95% confidence that our actual true coefficient ranges somewhere between this value. Okay, which we can say on average, as the year that a home is built increases by 1 year, we have 95% confidence that the increase in sale price will be roughly between $1,394 and $1,585.